What's good, you guys? In this video I'm going to cover another data type that's called vectors. In the previous video we looked at strings, which replace C strings, and here when I cover vectors this is going to essentially replace how you use arrays. So why don't we get started? So in order for me to use vectors I need to include the vector library. I can do so with the line #include vector. So how do I go about creating a vector? Well, vector, like string, and cout and cin and endl, they are part of the std namespace. But now when I create a vector, well, I can't just say vector and say v. No. Similar to arrays, I need to define the data type of my vector. So I use that with the angle braces. So I want a vector of integers, meaning array of integers if I was in C. I'm going to call my vector v, and I'm going to initialize it like I would in a C program. And let's put all even numbers here. So here I have a vector v. It's a vector of integers, and they're 5 integers, and they're even numbers. Equivalent to C, well, this would be the equivalent. And this kind of doesn't look too different. It's more of a formality. Instead of using braces to make sure it's an array, I just treat it like it's a singular variable, and I put angle braces around the int, and I put std vector before it. And if I wanted to create, let's say, a vector of doubles, I can use, all I have to do is change the int to double, and it'll work all the same. So how can I go about printing a vector like this? Well, there's a few ways. The first looks like this. Here I create a for loop that starts at the beginning of v, goes until the end of it, and I print every value. So I have a variable called j, and its value is the beginning of the vector. I'm going to keep going while I'm not at the end of it, and I'm going to be incrementing the value that I'm accessing by 1. And something to note is that j is a pointer. vBegin is a pointer to the beginning of the vector, and vEnd is a pointer to the end of the vector plus 1. So instead of pointing to 10, it actually points to the data space that's past 10. And I'm able to do this by using a nice keyword called auto, which we'll talk about in the next video. But why don't we see the output of this program? So it looks like my compiler uses C++98 by default, which is, well, we're in the year 2020, so this is pretty old. So what I tried to do here is I unsuccessfully tried to change the standard of my compiler to C++11. I was missing the dash, and I decided that, hey, I want to write modern C++. Well, if I wanted modern C++, I write it as 20, but C++17 will be good enough for this course. So with the standard of using C++17, I'm able to do this, because I think this was added in C++11. But anyways, I'll be using this to compile my programs for vector for the remainder of this video, and I could recommend you do the same as well. Why don't we run it? The idea here is that this kind of emulates the behavior of an array. I should specify a traditional C array. But the way of printing that I'm doing it here is much safer than with using C arrays, because I'd have to determine a size, I have to hard code the size of the value, and if I decide to change the array, oh no, I need to change the size number that I'm using for printing it, and it can get really painful. So like std string, std vector has some methods that are associated with it, and similar to std string, if you go to C++ reference and you look at vector, you can look at some of the methods that are associated with it. And actually here we have begin and end, which I was using here, begin and end. So feel free to go to C++ reference to see what they mean. Vector also has methods like size, max size, resize, empty, reserve, quite similar to string. We also have pushback, popback, insert, clear. Again, most of these methods are similar to the std string data type, and why don't I use some more of these methods here? Now we're going to showcase 3 of the methods that belong to the std vector data type. The first being size. On line 13, I want to print out the size of v, so I do so by saying v.size. And here I have it within my print statement. Next, I create another vector But instead of having it of integers, it's of doubles. And actually, why don't I show the C equivalent by creating an array like here. And we faithfully can't recreate vect into a C array, because with C arrays, they need to have a size defined to them, so that way the compiler can allocate memory for that array. But here on line 15, I'm creating an empty vector, which would be unheard of in C, because we can't create any empty data structure. We need to provide it some size, and the closest that we can come to creating a variable that doesn't contain any data or that's empty is just by declaring a singular integer, a singular double, a singular float, a singular character, or a singular structure. By creating an empty array, well, I'm sure you can figure it out in C, it'd be quite complicated and not as trivial as this. So then we move on to now that we have our vect declared, we want to check if it's empty. And since I just declared it, it is going to be empty all the time, so it will always print this. Then we demonstrate our third method, which is called pushback. And this is really nice because this allows us to dynamically resize our array, essentially. So here when I push back, I'm going to push back 3.14. And my vector will have size 1. It'll just contain 3.14. Then when I push back here, I will add 42 to the end of my vector, and it'll be resized. And vect will look like this. Where in line 22, vect was just an array of one element. Now on line 23, vect has been resized to contain two elements, two numbers. And on line 24, when I push back 36, it'll have three numbers. Just like this. I have a funky way of going about printing my vector. But this we will cover in the next video. But to give your curiosity a little taste, this is one of the best features that I love about C++. And it makes it quite modern and kind of brings it closer to the simplicity of other languages like Python. This is called a range-based for loop, where it will start at the beginning, go until the end, and print the variable j as each element of vector. So for this first iteration of the for loop, it's going to be vect of 0, then it iterates again, it'll be vect of 1, then vect of 2, until we reach the end. Fortunately for us, we only have a vector of 3 numbers, so then the indices only go from 0, 1, and 2. So why don't we run this code and see the result? And here we are. We print the size of v, which is 5. This totally makes sense since we have 1, 2, 3, 4, 5 values for this vector. When we create vect, we just declare it, so it's an empty vector. So when we call the empty method, it's going to return true, which for our if statement, it means that it's going to print vect is empty. But then we're able to resize vect. So I resized it by adding 3 more variables, 3 more numbers to the vector, and then I printed it using a range-based for loop. Why don't I show you guys about removing some data from the end of the vector and showing you another way of initializing vector. And here we are. The last line of our previous code ended on line 29. Now we have some additions from line 31 to 39. And we start by calling the method called popback. So as we have pushback, where we will add an element to the vector, when I call popback, it will remove the last element of that vector. This will leave us with a vector, vect, with only values 3.14 and 42. So popback will get rid of 36 because it's the last value. Then I go about printing vect again, so that we can demonstrate that we will only see 3.14 and 42. Another thing as well is that here I have a way about creating vectors. And actually I got this wrong. This should not be 9.2. I made a typo. And I should actually print the values here. So I will print this one more time. And instead of vect, we're going to have v3. But here what I'm going to do, and this is really a really nice way of creating vectors, is that you'll see that I'm creating a vector of floats. However, this first argument is an integer. Why is that? The reasoning is that this first argument is a size. So I'm going to create a vector called v3 that has 9 floats. And what's the second number? Well, it's a float, but it's only one number. Well, with this special way of creating vectors, what this statement means here is that v3 is going to be a vector of 9 floats, and all 9 of those values will have the value 0.47. So why don't we take a look at the execution of the program to verify that this is true. Would you look at that? First of all, pop back works. We were able to get rid of 36. And when I create my vector v3, which has 9 floats in it, we see that the size is 9, and every single one of those values is equal to 0.47 like I specified in the program. So this last way, what I'm showing you with v3, is a really nice way of declaring your vector, especially if you want to give it values but you don't know what you're going to do with them yet. Typically, when I use a vector like that for this last line, I usually do something like, I'll do std vector. I usually deal with integers. I'll say int, and let's say I just want 10 zeros, right? I can zero it out. Or I can say like len, where int len is, 15, right? So here I create a vector called x that has 15 zeros inside of it. And this is nice because just in case I need to do like a histogram or I need to take averages on this array, on this vector, it's super easy for me to do this because now it's not like an array where I have to declare the size of x and then have a for loop where I need to set everything to 0. Here it's all done in one line. It's easier to use and it's so much better, faster to use, and it's just more convenient. But this about wraps up our talk on vectors, and in the next video we're going to cover what this auto keyword means. And it is introduced in C++, more specifically I think C++ 11. And what auto does is a lifesaver, and it's especially useful for using in loops, especially loops like these, more specifically called ranged based for loops. Anyways, I'll see you there.